Example 17. The complex numbers z and w are such that mod z equals to 2, argument of z is equals to minus 3 pi over 4. Modulus of w is 4 and argument of w equals to pi over 4. Part A. Find exactly the real part of z. B. Find exactly the imaginary part of 1 over w. And part C. Express z squared over w in the form a plus ib. Solution. Given mod z equals to 2 and argument z equals to minus 3 pi over 4, we can say that z is equals to 2 cos minus 3 pi over 4 plus I sine minus 3 pi over 4. The question is asking us for the real z. So the real z comes from this portion, which is 2 cos minus 3 pi over 4. And we know that cos of the negative angle is equals to the cos of the positive angle. Therefore, 2 cos negative 3 pi over 4 is the same as 2 cos 3 pi over 4. And since 3 pi over 4 is in the second quadrant, cos is negative, but the basic angle is pi over 4. And cos pi over 4 has the value 1 over root 2, and we can simplify as negative 2 over root 2, and we rationalize it, you'll get minus root 2. Part B. Given mod w equals to 4 and argument w equals to pi over 4, therefore we can say that mod of 1 over w is 1/4 and argument of 1 over w is minus 1 over w. That is to say, 1 over w can be written as 1/4 cos of minus pi over 4 plus I sine minus pi over 4. And the question is asking for the imaginary part. So the imaginary part comes from this portion, which is 1/4 sine of minus pi over 4. Sine of pi over 4 has the value 1 over root 2, and we can simplify the value as minus 1/8 root 2. C. Z square modulus is equals to mod z square, which is equals to 2 square and equals to 4. And similarly, argument of z square is 2 times of argument z. Argument z is given to us as minus 3 pi over 4. Therefore, we can simplify as minus 3 pi over 2. Since argument of z square must be in the principal range, which is from minus pi to pi, then we need to convert the argument of z square as pi over 2 by adding 2 pi. We are also given w equals to mod of w equals to 4. Argument of w is pi over 4. Therefore, the z square over w modulus will be 4 over 4, which is equals to 1. Argument of z square over w will be pi over 2 minus pi over 4, which is equals to 1/4. Hence, z square over w is equals to 1 cos of pi over 4 plus I sine pi over 4. But cos of pi over 4 has value 1 over root 2, sine has the value 1 over root 2 as well. And we can rationalize it to get root 2 over 2 plus I sine plus I root 2 over 2, which is what is required in the question. Example 18. The complex number z is given by z is equals to cos theta plus I sine theta, where theta is between minus pi over 2 and pi over 2. Part 1. Show that the modulus of 1 minus z is equals to 2 cos theta over 2, and argument of 1 plus z equals to theta over 2. Part 2. Hence show that 1 over 1 plus z is equals to half times of 1 minus I tangent theta over 2. One plus z is equals to 1 plus cos theta plus I sine theta, just by substituting the z as cos theta plus I sine theta and regrouping the real, which is 1 plus cos theta plus I sine theta. The modulus of 1 plus z by definition is equals to the square root of x square plus y square, which is 1 plus cos theta square plus sine square theta. And by expanding the 1 plus cos theta square, you end up with 1 plus 2 cos theta plus cos square theta plus sine square theta. Sine square plus cos square is 1. You add to the 1, you get your 2 here, and remaining term is just 2 cos theta. The next step is to replace the cos theta by 2 cos square theta over 2 minus 1. Okay, so that 2 and 2 will cancel out. The remaining term left will be 4 cos square theta over 2, and by taking square root, you end up with 2 cos theta over 2 shown. Argument of 1 plus z. The argument of 1 plus z is equals to tangent inverse y over x, and y corresponds to sine theta, x is 1 plus cos theta, which is here. Replacing using half angle, sine theta is equals to 2 sine theta cos theta over 2, cos theta will be 2 cos square theta minus 1. 1 and 1 cancel out, you end up with 2 cos square theta over 2. By further simplification, you have tangent inverse, tangent theta over 2, and that will reduce to half theta shown. Part 2. 1 over 1 plus z is a division of 1 by 1 plus z. Therefore, the modulus of 1 over 1 plus z is equals to 1 over modulus of 1 plus z. And modulus of 1 plus z is 2 cos theta over 2. The argument of 1 over 1 plus z is equals to argument of 1 minus argument of 1 plus z. Argument of 1 is 0. Argument of 1 plus z is half theta, and you end up with minus half theta. Therefore, the complex number 1 over 1 plus z is equals to 1 over 2 cos theta over 2 cos minus theta over 2 plus I sin theta over 2, which is the polar form. And because cos of the negative angle equals to the cos of positive angle, sine of negative angle equals to negative of the sine angle, you end up cos minus theta over 2 as cos theta, sine negative minus theta over 2 is minus I sin theta over 2. And by simplification, cos and cos cancel, you end up with 1, and sine over cos is your tangent. And this is your final answer. Note that as z is an unknown complex number, the graphic calculator cannot be used in this case.